learn more about charging and constant current, constant voltage, the life in chapter 7, which will be on battery charging and swapping. I hope you have gone through chapters 5, which will be on battery pack design, mechanical, thermal aspect, and electrical and BMS. Hope you have learned motors and controllers, so that you know what is the requirement from a battery. And we will come to nearly the last chapter, chapter 7. Chapter 8 is a small chapter on managing the charging infrastructure, managing and analytics, managing the infrastructure and analytics. But here we will be discussing battery charging and swapping. Remember swapping that we had introduced right in the beginning in the first chapter. We will look at the more detail of what is involved in swapping also out here. This chapter is also a little bit older, bigger chapter. We are going to do introduction of EV charger, we will define what is called slow charger and fast charger, we will define swapping, we will talk about why is standardization required, charging standards, we call charging standards, why charging standards required. Then I will define what is called onboard chargers, a charger which is with the vehicle. There is a public charger which is sitting outside, I will define what is called bulk chargers, which is used in swapping. And then just like I did a economics of battery, we will do economics of public chargers in Indian context, again taking into account the interest rates. Once again you will find that if you do not take the interest rate, you get one result, you take the interest rate, results changes completely. Let me start with simply charger introduction. If you remember, we had started talking about charging in chapter 4. Review that last small section, it will help you. But basically, we will get into details of that in this chapter. What is a EV charger? Well, basically something that charges electric vehicles. Actually, it charges battery of the EV. It is not, does not charge EV, it is charging the battery of the EV. It is very similar to that way a cell phone charger that I use all the time, or a laptop charger. It charges this, you say charge a cell phone, it is actually charging the battery of the cell phone. We say it is charging laptop, it is actually charging the battery of the laptop. Similarly, EV charger will charge the battery of electric vehicle. Basically, power will be taken from grid, electrical grid, and put into the battery. What is the difference? The primary difference is much larger battery, therefore, much larger charging currents, could be even charging voltage. Grid pretty much all over the world is usually AC, and typically in most countries it is a single phase and 3 phase. I am going to primarily talk about India, there may be small variations. Europe has very similar small voltage difference. In India, for example, single phase is 230 volt AC, and you can get 15 ampere current, or 3.3 kilowatt. So, you have these plug points that are bigger plug points, the kind of plug points that you can see even in things like this place, the bigger plug points, thicker, bigger connector, that is a 15 ampere socket. That is used when you are going to use a refrigerator, where your air conditioner, it is a must, for your washing machine it is a must, for your electric heater it is a must, for the mixer you can actually use both. Low, now the motors are becoming smaller for a mixer. For a grinder, again it comes somewhere in between. So, 3 phase is commonly used. So, single phase is 230 volt AC, 3.3 kilowatt. So, typically under 3 kilowatt charging, whereas if you want higher, you go for 3 phase 415 volt AC up to 50 kilowatt. In fact, higher also you can go 200 kilowatt also, but the standard definition is 125 amperes. So, for even higher power, for more than 50 kilowatt, one has to take grid input at a higher voltage and would require a transformer. This is something single phase and 3 phase comes to every home, every office, every factory. But if you want even higher voltage, higher power than 50 kilowatt, you normally have to get a higher voltage line directly from the grid and probably use a transformer and do things like that. Sometime even if you go over 15 kilowatt, the electric grid company, the power distribution company may say, no, you need higher to tap the power grid, but otherwise single phase 3 phase is commonly available. So, you have this one difference will be, unlike the sockets that we use at home for a single phase and 3 phase, we will actually use what is called industrial sockets. And industrial sockets are also available on different rating IP44. IP44 for example, is a socket where this pin is inserted, the socket is I think, is this a socket? Well, I don't. I think socket may be given in the next slide. No. So, it actually gets connected, similar 3 pin, it gets locked. So, this is the socket and this is the plug and a socket will come. I think this is a socket, probably I did not show you. This is a socket and 3 pin, the two together, and these are normally industrial plugs. These are single phase, but then there are 3 phase sockets also. The 3 phase, there are 3 phase socket. So, this is 2 phase plus electrical. So, 2 phase plus, so this is a socket plug and the socket. This is for 3 phase plus neutral plus earth, and this is IP67. IP67 basically is an industrial grade, but also can handle things like if water comes in, it is a waterproof connector. So, this is a waterproof connector and this has a 5 pin 3 phase plus N plus E. This is the sockets that are available. This can do up to 50 kilowatt quite easily. Okay. So, for a smaller vehicle you will almost always use something like this. Can you use the standard 15 ampere socket that is used at homes, single phase? Well, yes and no. You know, number of times that socket can be charged, removed and connected again and is limited. So, if you are going to have a EV and you are going to do it about 1000 2000 times, that no longer remains reliable. So, you will generally prefer to use something like this. So, if you do use something like this, then you will have to be prepared to replace that. Okay. What does a charger consist of? It basically is AC charger. Always AC will have the protection and metering here. There will be invariably protection and metering. Then there is a AC to DC converter, essentially a rectifier to the right voltage, and the voltage is controllable. There will be normally a processor which will be communicating with the battery vehicle, and based on that it will control the voltage, the DC voltage. DC voltage is controllable. You will then put some DC voltage protection, because you do not want anything to go wrong if something goes wrong here, and then you will get it to the EV battery. Since battery is charged by DC power, a charger is normally AC to DC converter. It has a protection at the input as well as output. It will invariably have metering at input. It may have current and voltage control, because depending on what the battery require, you normally will have current and voltage control. A battery voltage changes during charging continuously. So, you should have a voltage controller and you should have a current controller. CV is usually the maximum voltage to which battery is charged. So, that is what it is. Additional interfaces, this was a simple charger. A charger may be optional for a simple, very simple charger, this is all that is there. But as the charger becomes more sophisticated, you will see there is a communication interface to energy operator. Whose energy? Your DISCOM. You want to tell them that so much power I am taking. Not just for metering, but actually it helps this energy operator, if it gets from every charger. The charger is a large load, could be a 30 kilowatt load, 50 kilowatt load, and this can be turned on, turned off depending on whether it is used or not. So, the charging, the grid will know that this is what is being drawn, and it can adjust its supply demand in such a supply in such a manner that you can service this. It manages power drawn from the grid. It can also do billing. Metering is done here. Billing it can do, saying no, this you charge at a special rate, or this time of the day I have a shortage and is trying to draw too much power, charge them heavily. All this can be done by communication with the energy operator. What kind of communication interface it is there? Today it is invariably wireless. 2G, 3G, 4G is used for this communication. There is typically a payment gateway in the charger. You go to a charger, you put your vehicle for charging, you can swipe your card or use mobile phone for sort of saying, well, finish charging and my payment can be done from this account. So, invariably there is a payment gateway. Public charger, this is very important. If it is a private charger, which is you just use it for yourself, this is not important. There is a communication with the vehicle, and this is important, particularly when you are charging fast. It tells you, well, charge slow, charge fast, do not put so much current. Now, I have reached, you go to constant voltage, what is my peak voltage, all this is done, because different vehicles may have different peak voltage. All this is done with communication with the vehicle. This is invariably wired, just like the charger is always be wiring. So, there is going to be the sockets, the cables for charging, power cables plus communication cables. Together both of them can be in a single socket. And so, there is a grid connector and there is a vehicle connector. Normally, this communication with the vehicle and vehicle connector. This is the power, this is not power, this is communication, the two can be integrated. Okay. This is what a full charger looks like. Well, this is a block diagram showing the same charger. If I look at it, typically there is this part is vehicle, this part is vehicle battery, this part is the charger. If you look at it, this is communication. There is a communication unit, charging control unit and charging control unit in the battery, could be your BMS, and the two will be exchanging messages. And this is the commonly method that is used for exchanging messages is a CAN messages. CAN is a protocol, control area network, physical cables are defined and messages go back and forth onto this. So, messages will go, plus it will also have some individual CP, CP2, CP3 which will also be used for charging. this is where the power conversion unit from the input, and the power is converted to DC, and the DC is brought into battery. There is invariably a relay which can be switched off at any time. So, this gives you protection also. Then for some reason what happens if this is shorted? So, you have various earth leakage and there is a earth point also brought in. So, this is a typical AC charger, this is a typical AC charger, and this is how it connects to the battery. This is showing the same level 1 and level 2 AC charger. This is a AC charger which will come in, and it has 2 kilowatt to 20 kilowatt single phase or 3 phase AC supply. This is a fixed AC supply. This is a simple, it does metering, billing and some safety interlocks, and then gives you out. That is all, the same AC out. And actually charger, in the AC charger, charging conversion is not done in this part. This is the public part. This is your private vehicle charger. The vehicle takes in the AC, it does the rectification to DC. The level 1 charger or AC charger, level 1 and 2 charger, it does conversion to DC, and then this is the DC charger, DC-DC converter, and then it communicates with the protection unit. So, it is a part of the vehicle. This is a part of the vehicle, this is put inside the vehicle. You just take a AC and connect it, this is how I do, this is put inside the vehicle. This part is built into the vehicle. You can of course have separate AC chargers, and then you just put the battery monitoring and battery, but these two are highly integrated. On the other hand, if you do DC, here AC to DC supply is done in the charging station, and the DC charger simply puts the protection circuit and BMS and charges the battery. So, if I take a public AC charger, this is the public interface. This side is giving you AC, this is giving you DC, this is called level 3 DC charging. Okay. Invariably there is a communication and safety interlock that is there in both AC and DC charging. And here the difference is, here the converter is here, and here there is no converter, because directly DC charging. Protection is invariably there in this. So, what are some of the parameters of importance? The first parameter that I keep on worrying about is I am taking this grid power and giving it to the vehicle. What is the charger efficiency? Why is that important? If I say it is a 90%, well, 10% of power is lost, not just lost, it is converted to heat. Now, I have to worry about heat dissipation. If it is 85%, 15%, it is a large power. I may be drawing 20 kilowatts, 3 kilowatt will be lost, huge heat. So, I generally tend to have it higher efficiency. If it is a very low power charger like Hannes is designing, then 87-88% may be okay. You lose 10% of 3 kilowatt or 10% of, let us say, 1 kilowatt or 2 kilowatt, 100-200 watt. But for large charger you can't afford that, you will have to go 95, 96, 97% efficiency. Charger protection is an important parameter. Both the charger, the grid has to be protected, vehicle has to be protected, all three. Power factor is another very important thing. You are drawing power from the grid does not want you take reluctance power. So, if you have designed the charger, particularly your converter, which tends to take a lot of reluctance power. That is extra load on the grid without they are getting paid for it. So, the grid may say do not do anything less than power factor of 0.95, 96, and you have to comply with that. Of course, charger cost is an important parameter. Then there are what is called on-board charger and off-board charger. What is the on-board charger? It is a built into the vehicle, dedicated to the vehicle, either dedicated or in between the vehicle. You can keep it separately or inside the vehicle. Maybe portable or non-portable, that is what I was saying. It can be portable, means you can take it out, non-portable means already fixed. Is normally sold with the vehicle and correct typically to have AC socket. The charger always has the plug point, it goes and plugs into a AC socket. Two-wheeler and three-wheeler chargers with level 1 and 2 chargers prevalent in Europe and United States. There here, since AC is the input, rectifier is in the vehicle, in the onboard charger. It adds to the vehicle cost, but if it is a low kilowatt charger, it does not add too much. It must be very low cost in Indian market. We will look at this in the end. Can connect to a single phase or three phase depending on amount of current that it is drawn, or power sockets at homes and public places. So, this is on-board charger. Off-board charger is a charger which is not with the vehicle, usually a DC charger, usually. Charger can be installed in public places, sometimes all bigger DC charger can be installed even at your home, but there is an extra cost you have to pay if it is a home, it is a big charger cost, and vehicle can plug directly into the DC socket. So, off-board chargers are typically DC. So, this is all that I want to do as a very quick introduction. Later on, I am going to look at what is a slow charger, what is a fast charger, and what does it really mean. And remember that this kind of picture I had shown you earlier, what happens when you try to fast charge, what happens try to charge slow. This is what I will do in the next lecture. Thank you.